session, Igniting Innovation Using Data and AI to Automate a Heat Treat Operation. Learn how to collect and use data to observe, react, and optimize heat treatment processes, seamlessly connecting operations with administration using automation and artificial intelligence. Discover how this integration enhances efficiency, minimizes errors, and unlocks new insight for a more efficient heat treat operation. Please welcome our speaker, Mr. Sefi Grossman.
Thank you. Thank you. Thanks for coming. So before this, we had another session about getting your data prepped. But obviously, this is the more popular presentation and got a lot more people here. So I'm Sefi Grossman. I'm founder and CEO of Combustion OS. We are a fully integrated ERP system specifically for heat treat. Myself, I am by trade a software engineer coming into this space from a different perspective. And today I'm going to talk about, at a very high level, just the different aspects of the heat treat operation and where AI is currently and will transform the industry. Real quick before I start, how many you here are heat treaters? Okay, and how many are software engineers? Okay, so I'm going to keep it very high level, but I'll squeeze a couple little things there for you too. So it's the only eye chart, I promise. So why and how is AI improving heat treating? So first thing, obviously, it's all about optimization. The last session we had was about optimization and how you reduce errors, human errors. But now that we have the ability to capture data more efficiently, and we have all these new integrations with hardware, we're able to not just monitor things as a dashboard, but actually be able to get some insights. So as you collect data over time, a system is able to learn and be able to see when things are out of place and actually create suggestions that normally would take a human to look at or interpret. But with the massive amount of information and data, that's almost impossible. And with AI and machine learning, you're able to be able to interpret things in a way that were never able to be done before. Quality control is one of the first things that come to mind. Obviously, you want to have the ability to detect when things are off or any anomalies. And this is where there's always a push. And this is where, from an industry point of view, is always the ability, because it affects not only your operation, but also where the material is ultimately going to end up. And so when you're able to catch those things automatically using AI, that's going to be a huge advantage, not just to your operation, but also to the industry as a whole. Predictive maintenance or preventative maintenance, a lot of that is just traditionally the ability to go through and make sure you are checking everything in time. But as data now is able to be digitized and no longer just tracked on paper, you start to be able to pick up things that normally you wouldn't see for potential equipment failure before it happens and before you get downtime. So that's a big one. There's a lot of solutions on the market for this. There's also the ability to integrate that into a bigger picture, which I'll talk about here in a minute, to make it even more advanced. Obviously, you want to look at decision making. Typically in your operation, you have somebody or a couple people who really have been there for a while. They really understand the operation. They have an instinct to things. AI allows us to now take a lot of that knowledge and even enhance it by looking at a history of information that's been collected about work orders or your equipment, and now be able to make decisions that are going to be an enhancement to the human. It could be even how you create your recipes, how you make adjustments into your current process, and even scheduling, the most optimal schedule to run in order to get there, so you don't have to do a lot of those things manually. Kind of a benefit, I think, of a lot of that energy efficiency. So that's a big push, I think, for industry as a whole, is to be more energy efficient. So you don't want to run things out of order or continuously do things that are not efficient as far as your cycle times. So energy consumption reduction obviously is going to have also a direct effect on your cost, your operational costs. And so the rest of it here too, streamlining your workflow, again, similar to scheduling, you want to be able to make your system adapt. So as you're getting new materials, new processes, the more information you already have, the more suggestions can happen. How many guys, just for a quick question to the audience, how many use some sort of AI today? OpenAI, ChatGPT, a little bit? It's okay. It's the way of the future. Everyone should. It's great. However, you know, a lot of those systems, you have to input all that information in. So if there's an integration in there, that will allow you to actually allow those systems to learn from what you currently have. But the trick is, how do you integrate it and how do you get the data in the first place, which, again, we talked about earlier in an earlier session, but that's a big piece of it, so that we can learn from the past when it comes to, you know, potentially new processes, any changes you have to your equipment, all that can automatically happen. You want faster turnaround. Everybody wants faster turnaround, so we can optimize, again, scheduling, customizing your specific, you know, customer needs. So you're going to have certain situations where you have a lot of variability. AI can help you there. And then obviously this is where everything's going. So anytime you bring AI into the fold, into your operation, and you can talk about it and show the benefits, you're going to have customers are very happy about that. So does anybody, you guys have an idea how AI works in general? A little bit? Not too. So a quick little primer. So traditional programming, you write it very specifically. So you write code that just does something. As you put it, you can still put logic, and if this happens, do that. You know, you might program your PLCs or your software. It has a very specific set of instructions. And it can adjust, but you have to do a lot of those things manually. AI, completely different approach, is you just give it a bunch of information with a particular outcome, and it will actually learn and adjust automatically without you having to dial it up. So that is it's a huge example. So, you know, for example, in a traditional programming setup, you might have a new heat cycle with different material, and it could take time to be able to adjust that, but AI can automatically look at the previous history and make those recommendations for you if it had all that data already in there. So obviously it gives you more flexibility, but it speeds up the process and accuracy as opposed to something that is more traditional. And this is a little bit of example. You know, you take your data, your programming, put in a computer, get an output. The difference is that the output here is something you already predict and know how it's going to happen. Here, the software actually decides and makes those determinations instead by giving it the end result back into the system, and it will learn from that. So it's just a little bit of a paradigm shift. So there's different types of AI. There's rule-based AI, which, you know, automates, you know, very simple tasks that are, you know, could be alarms or just looking for certain anomalies. As you get a little bit deeper, you get into machine learning. This is where you start to predict things. This is where you're starting to feed a model, as they call it, of data that will be able to produce and look at historical information and give you, you know, predictions or adjustments. And then we look at, you know, going further down into deep learning. And this is where you can detect very, very complex elements that you normally just cannot see, no matter how good you are in your trade, because it's multidimensional. There's so many different factors that are not obvious. It could be equipment input. It could be who's operating a piece of equipment. It could be the humidity. It could be the temperature. There's so many different factors. And deep learning is the ability, using neural networks, which I'm not going to get into too deep, but it has the ability to find the patterns that again, we normally can't see because we're, you know, from our point of view, we only see like 3 dimensions. It could see like 10 dimensions of different information. And then the last piece, and this is a big part of this process, is just reinforced learning. So it doesn't just automatically figure things out. You're continuously, as a team, inputting information into a system and giving it different points of view. It will learn from those interactions through a little bit of trial and error. So it's not AI is not an exact science, but along with continuously feeding it new information, you'll be able to get more accuracy. So a quick prerequisite, like how do we get to using a lot of these AI systems as opposed to maybe what you're using today? So obviously data collection is the most important piece. It's being able to use your existing systems, being able to export this and put them into some kind of structured database so that the data is clean and it's uniform so that we can put it into a data model. The more integrations, the better. So as more systems and hardware becomes available that you can interact with, whether it's a direct integration or maybe a Modbus integration, you're able to pull a lot of that raw data that might be meaningless, but there's a lot of hidden gems in that information that through the right AI process, you'll be able to pick things up that you guys would not be able to see normally. And then obviously you need some platform. There's got to be a software platform that you can upload, process, and be able to give you a human readable output of what you're looking at. So this is the kind of general process of how you even get into AI in the first place. So I'm going to walk through a few examples of the opportunities of where AI is currently and is in the works of being done. So talk about quality control. So computer vision, this has been around for a little bit as far as the technology, both cloud-based and on-prem based, but the ability to be able to detect certain anomalies or elements that the system will learn over time could potentially be a defect. That just gives another set of eyes into like a lab environment when you're able to integrate your existing hardware or testing equipment and be able to analyze that. So you'll be able to suggest or look at certain things. So imagine just having somebody else that doesn't miss anything look over your shoulder and make sure you're doing everything correctly. And based on that input, we'll be able to tell if there's issues with like lab samples and so on and so forth. Process scheduling. So as you have your process schedule, there's different, depending on the equipment you have and your process, there's going to be a lot of different variations as to how long things take to process and being able to even estimate how long things are going to take to get done. And so there's a lot of, again, data inputs and a lot of AI factors that will determine that. So what is the status of the equipment? As you have equipment that's either online, is it running correctly? How much capacity can something take? Again, I was talking about earlier, what are the environmental factors of the shop at the time? The complexity of each part. Is there a changeover if you're doing continuous? Is there a changeover time to reset and recalibrate between like work orders? Who's working? Who's operating a piece of equipment? And then what are those unexpected events that happen? So you collect all of this information, which is available, just needs to be digitized. And with all those different factors, be able to actually give a good prediction without even having to understand exactly what the equipment does. And this is a very interesting, concept. If you're trying to estimate, and I'll just take a continuous furnace, for example. If you're trying to figure out how long it takes something to get through, you're going to be looking at your cycle time and trying to calculate that manually off a chart or whatnot. And you would think in a software package, you'd put that in and look at the recipe and saying, well, this is running at 29 hertz. I know exactly how long it's going to go through the machine. But there's things that slow that down. There's problems, things get stuck. That can be learned over time. And again, it might be who's operating, all those different things. So when you take a history of 6 months to a year of data that's collected of all these different factors, you're actually able to more accurately predict how long something is going to take to get done. And that'll give you a more accurate time, as opposed to just trying to calculate it through a traditional manually done algorithm. So that's a very interesting opportunity for AI in process scheduling. Recipe creation. So as I've seen this in medical and a lot of other fields where there's this field of knowledge that is gained over studying and time, and obviously metallurgy is a big part of that, but now we have the ability, without having to teach a system everything before it does it, is I learn from previous, especially when it comes to certain materials, that you can start to help create suggestions. So just like you guys might be using some of the existing AI tools in your Microsoft Office or your Google Sheets, or if you're going outside into something like ChatGPT, that's kind of useless when you're trying to create a recipe. But if you had the data available and put in there, it could start making suggestions to really help enhance or maybe eliminate mistakes when you're going through your recipe creation process. So incoming. So if you're commercial and you're incoming and you want to be able to reduce the amount of time somebody's taking doing data entry, we have the ability through a mix of a couple different technologies. So first one, which everybody already has like on their phone right now or on the computer, is optical character recognition. So this is the ability for a computer to look at text, typically printed on a piece of paper or a shipper or BOL, and be able to actually read that in. So that's just getting it into digital format. But the AI side of it is to actually be able to interpret what that is. And the benefit, obviously, is that as you're collecting that information, you'll be able to know, even if it's a different format or different customer, what that field is, so you can auto-populate all of your ERP information. So this is a huge advancement in data accuracy, but also just speed. So people spend less time in front of a computer, data entering everything in. And it doesn't take anything crazy as far as hardware. It's just a simple scanner that has some kind of FTP or network ability, so that a system can pick it up automatically and fill out your paperwork. So all that, again, from an AI point of view, is a huge enhancement to your incoming process. So preventive maintenance. So this is, again, a huge opportunity for AI. So we usually it's either preventative, predictive. How do you get to real predictive, right? There's a lot of factors, and it depends on the equipment, the hardware, and specifically what component we're looking at. So motors have certain characteristics. Your furnaces have different characteristics. So obviously we need to collect certain data, but it's not just about the integration itself. There's a lot of outside things that might seem obvious, but it's all part of the big picture. So obviously how long something's been running, that's going to be a big factor. So if there's a piece of equipment that over time either has a documented runtime or life cycle, that's obviously great information. But sometimes it just happens. You don't really know when something's going to break. But if you collect it during your PM process, so when you know something is not functioning, you're able to track that down, even if it's just looking at how many hours it's been running, and be able to document that automatically. Number of cycles, so depending on, again, type of equipment, how long something opening and closing, heating, cooling down. Obviously, that puts a lot of stress on any piece of equipment. That's something we want to collect and track and put into a system to be able to add to the prediction. Are you high usage, low usage? What are the sensor readings? So if the more sensors we have, the better. It doesn't always mean that the sensor data is going to tell you everything. So in AI, there's this concept of causality, and it essentially means that there's certain data points that if you read them correctly along with others will give you a good prediction. There's also a significant amount of information that's meaningless as far as what we need to look at. So you want to make sure, when we're looking at sensor readings, that we have the right sensors. Sometimes you might have to add additional sensors that are not part of your current setup. For motors, for example, it might be a vibration sensor, because that's where a lot of telltale signs when motors start to go out is when you're seeing certain fluctuations in something that has an accelerometer in it. That's not something that typically comes with, out of the box by just looking at voltage. So I was talking about like past maintenance records. This is where you can kind of learn from your particular setup, things that have happened in the past when things have been replaced. There's a lot of information here that's not necessarily a connected piece, along with the downtime patterns. So when things have downtime, the longer you take and more information you collect, the better and more accurate that's going to become. Talk about environmental factors. Any different things are specific to that piece of equipment. So if you're able to continuously monitor oil, coolant, lubricant levels, all of that is obviously going to be a factor. And then also operational behavior. So how many times something had to be stopped or adjusted, that's data that's useful into AI. Are we sticking to our maintenance schedule? So earlier said we were talking about how to automate a digital PM system, which is great if you just want to collect it and audits come around and you have all of your stuff filled out, which is great. But if you had that data digitally and you want to be able to look at your maintenance schedule, make sure that everything gets done correctly, that information is also, again, incredibly useful. The rest of it, I think it's kind of goes without saying how old the equipment is and any other, what you get out of the box, what are the recommendations from the OEM as far as how long it's going to, how you maintain it, everything else. Those are going to be part of the equation, and then just general energy consumption. So is it taking more energy than not? There might be a problem. So all of these things are things a lot of it you do today. Just what you analyze. But if you can put them into a data source, a lot of that could be automatically inferred as opposed to having to do it manually. And then another opportunity, and this gets a little more into like the ChatGPT stuff, but it's once you have if you have a digital system and all your information in there, this is where it gets kind of fun. You can actually imagine talking to your system. So this is where you have the opportunity to do things like you would with your Amazon Alexa or ChatGPT. And instead of digging through things, even if it's on the computer, even if you have a dashboard and you have a phone call and you're trying to figure something out, the ability to just ask a question through chat or text your system and have it be able to decipher what it is you're asking and be able to pull in. So for example, if you're don't want to look at a readout, hey, what's the current furnace temperature? Are there any maintenance alerts? Those sort of things. Whatever's available in the data can now be converted into a ChatGPT type interface, which is nice if you're just looking for a quick answer, especially if you're on your phone and you just want to pull it up and text your system. We're now entering the realm where your system is it's a being and you can talk to it, which is awesome when everything's connected, all this technology. And this is not anything that is, by itself new. It's just sat over here on the side. And now we're able to take all of our data and put it together and start to take advantage of these sort of things. So just a few case studies in other industries. Obviously, this is relatively new in heat treat and something we're doing, but just a few other kind of scenarios. So GE, they implemented AI monitoring for their jet engine components, and so they were able to reduce a lot of engine failure, be able to optimize their component lifetime, their maintenance schedule. So definitely in aviation has been a big push to get that. And again, they have to make sure that their data is optimized and put into a data structure that could be used. A lot of smart. So as we get into smart factory, which is a big part of this conversation, has not been as much a factor in heat treat, but it is now. And so the ability to be able to integrate and consider like the equipment status and everything kind of going. So Siemens did this, and they were able to improve their efficiency by being able to reallocate work orders, which is the same thing you guys could do, especially if you have a lot of furnaces and something goes down, and now you want to rearrange your schedule. Well, that's a task that can be done automatically based on all the rules of what you need as far as priorities. So that sort of thing, again, very possible and doable in heat treat as well. And then computer vision. So ThyssenKrupp did an AI-powered computer vision. This is similar to what I was showing you earlier with some of the lab work. Is they're able to inspect steel components and look for defects. So it's obviously already been done so that they can not rely on just someone looking at it by eye or using their experience. You could take hundreds of years of experience and be able to put that into one system that will automatically be able to detect and see those things. And I would say none of these replace the need for the human component. It's just another enhancement to the process that's there. It doesn't miss things like you would, or it's not dependent on the condition of who's inspecting something, or if they're tired, if it's 3 a.m. It will do the same thing every single time and be able to do evaluation. So all these are great case study examples of other industries where AI has helped. So a few key takeaways, and then I'll open up for questions. What aspects are we looking at where AI is going to revolutionize things? Again, very high level. Each one of those slides could be its own presentation, but this is just kind of get the conversation started. So enhanced quality control. So obviously we want to be able to detect defects, see anomalies that you normally couldn't see. That's going to be I think a significant push in this industry, especially when we're looking to run things more efficiently and reduce waste and make our customers happier. We want to optimize scheduling so that if things need to be reworked or something, you get a phone call and a certain customer wants their stuff rushed. Instead of the task of trying to refigure that out, you can put that into the system and have all of your schedules automatically reassigned, especially with any complex furnace setup you have. It can absolutely do that. Data process optimization. So we want to, so AI uses again the history of everything that's going on. So anything that we want to optimize as far as efficiency, energy consumption, that's going to be all done through the data collection process with AI, predictive maintenance, helping us create an accelerated recipe development and improve our recipes through AI, energy efficiency, and honestly to get everything future future ready. There's going to be things that we didn't even imagine that are possible to create the most streamlined, lean operation possible. And really the way I kind of look at it is, how do we take this industry as a whole and be able to make it more of a technology-based. Think of yourself as not just heat treat, but like a technology company. And then instead of software helping our human components, like the software is there to help us as humans. The shift is now we have software that needs us as humans to help it do what it's trying to do. And that's the paradigm shift that's kind of hard to especially if you've been doing this for a long time or if you've been using software, to really kind of grasp around. But once you have that, the efficiency that runs and the predictability and the ability to scale is unmeasurable right now. There's so many opportunities, as you can see, just from getting your data into a central place. So, any questions? Good question. So there's the cloud is going to give you the most ability to look at information over time, but most of those systems that you have available will lock in and not share any of that information. So there's this kind of fear of taking your data outside of your facility. There's more fail-safes in the cloud, and depending on the environment you're going to, whether it's Amazon environment or Microsoft environment, those are extremely locked down and don't get shared with anybody else. There is, though, on-prem abilities, and it's more like near-term or short-term. They call it like edge computing. And essentially, you're going to be looking specifically at a piece of equipment and looking for variations, and that does run AI software locally, like right next to the equipment, that's looking for like near-term fluctuations. So you have like your right now stuff, and then you have your long-term. This is like collecting data over a year, 2 years, and you're able to start to see the patterns. AI essentially, even the ChatGPT stuff, it's all pattern recognition. You're just looking at it at such a high level. It's almost like magic how it works. But ultimately, all it does is look for things in the probability of how close something is. The more powerful, the more data you have, the more power you need. Generally, you're going to want to go into the cloud. But if you're looking for some kind of short-term, kind of analyzing something that's happening on a piece of equipment or something local, you can run that on premises on a server that you're running in your shop.
Yeah, because my understanding that if you go to the cloud for this information, there's all this other information out there that might not necessarily be pertinent to you, but it's going to use, and it may give you the wrong answer.
Yeah, and so if you're looking at like large language systems, like in like OpenAI, ChatGPT, that's different than actually creating your own model and being able to analyze just your data. So, and there is a benefit sometimes that if there is existing models, so essentially, a model is the output of training so that it has like so you educate a system that this is what it needs to do. The data points that create that model, to your point, are affected by maybe outside factors. Sometimes it's an advantage. If you have a piece of equipment that's already been, distributed to 100 other locations, you want to get that knowledge. So you want to get that federated knowledge just for that piece of equipment. So that is something you do want. Not general, but specific model that's created for a particular piece of equipment. However, inside your operation, you can lock it down to just your data. And you're training it just on the information that's been coming out. And that's why it's not like an overnight thing, because you need to start collecting data, train it. You need events to happen. So things have to happen for it to learn and adjust to. And sometimes it's pretty quick. If you're talking like tons of data coming out of a machine and something's happening, it could be minutes, or it could be a couple of years. It just depends on what it is you're trying to analyze. And it's something kind of gets better over time. Because there is a learning factor and it's not explicitly programmed. Yes, sir.
I just have a question. If there's, this has been much, or to set up a scenario. If you have a extremely non-uniform part that is a batch process, but the temperature distribution across the part through an array of load TCs
Mhm.
is crucial. Has this sort of technology been applied to something like that?
I don't believe so, but it is something that is evolving. And a lot of it is just getting the integrations first to get the data points. But now it's all available, so that is, it absolutely can do it. This is a fairly new space, and the main reason it's not even the AI being new, it's just nobody connected the data together. You've collected data for a certain purpose of storage and compliance and making sure that that is available, but it's getting it into a format. So there was never a need. Now you have the need, so you look for those opportunities to collect it. So that it's absolutely possible, but now you have to say, all right, what do I need to do to bridge the gap? I want to create this kind of prediction, but I don't have any data. So that in between place is like, how do we integrate those tools? And you're looking at your hardware, you're looking at your software integrations to be able to get it into a uniformed data set to be able to do predictions on that. Cool. Yes, sir.
So I was wondering how streamlined of a process it would be to tie in your furnace PLC into the server to extract the data, analyze it, and then have all the measures that you mentioned, like preventative stuff like that, integrated into the furnace so that it can collect the data and then analyze it for future reference. How streamlined of a process is that?
Extremely, but usually takes like a couple steps. So the first step is obviously to stream the data into something that's very close to the equipment. So we'll call it on edge. And essentially, because there's just a tremendous amount of information that's coming. Let's just say it's a Modbus integration to a PLC. You're collecting tons of register data. It by itself, as it is way too much information and kind of meaningless at the time, right? So you start to collect that and to summarize it locally. It's the sum of that information of what it actually means that is what you are going to process into AI. So if you have, for example, you have a PLC that's opening, closing a door, right? And you're looking at the timing of how long that takes. It's not the zeros and ones that tell you when it's open or closed. It's the timing of data captured on a time series, which is most of what this is time series. Go a little bit deeper. So it's not what it is, it's what it has done over a period of time. That time series and that event there's a number that comes out of that, and that's literally the seconds it took. That's what actually gets stored and logged into what like a database, and that's what you're trained on. But that's very specific to that piece of equipment. So everything is tailored to what it is, and you need to know what you're going after. You don't just throw AI at something and just say figure it all out for me. You have to have an idea of what you're trying to prevent or what the issues are. And most people do. They know where things kind of break. You just want to get ahead of it sooner, and that's where when you analyze that piece of equipment and it pulls, you can streamline that very, very effectively. But it usually takes, again, two steps to take all this data, condense it, and then take that inferred data, and that's what you actually learn on. I think we're at time. If anybody has any other questions, by the way, I'll be at booth 722, so please stop by. Got a lot more fun stuff there than necessarily here in this presentation, but we'll love to see you there. So thank you very much. Appreciate it.